Chapter 16 is on the agenda. Watch what you eat and avoid Splenda. What? Wait a second. With the popularity of my videos, there's the potential that if this goes global, people would stop eating Splenda left and right, and they could sue me, and this is on the web. Splenda is great. You can eat Splenda all you want. I didn't say that. We are on, come on now, Chapter 16, Lymphatic System. This will be in 2 parts today, Part 1, Part 2. And then there will be, I should say, Part 1A, Part 1B. Part 2 is later, and even more detailed. So get your fill of some of the easy stuff today. We are talking lymphatic system. There's 2 semi-independent parts. There's the vessels and the structures that those vessels connect with, the various tissues and organs. And their main functions are to move fluids back to the blood meaning from the tissue fluids back through the vessels into the bloodstream, and then also playing a role in body defense. So let's go through these details here. Lymph is the stuff that carries these things. It's the fluid. So when I go bow, you probably couldn't see that. Let me show you more closely. Bow, and I pop a zit. That white stuff that comes out, that's not lymph. But the stuff that remains after, and you look 5 minutes later and you see this clearish kind of ooze coming out, it's yellowish, maybe it hardens, and you kind of pick it off and flake it, and you're like, ooh, that's interesting. That is lymph, that clearish stuff, and that has white blood cells and so on, and proteins in it. Now, lymphatic vessels only move one direction. The flow only happens one direction, from the tissues back towards the heart. There is no pump. And the only way that they move is from the milking action. Yes, I am milking something with my skeletal muscles. The milking action of the skeletal muscles helps to move the lymph through the vessel one direction. And then also the walls themselves of the lymphatic vessels have smooth muscle, and that smooth muscle helps when it contracts, or it causes slight constrictions, and that moves the lymph through. So the vessels, if we look at capillaries specifically, they have walls that overlap themselves partially, and this creates a little flap-like valve. And this allows, if out here is the tissue fluid, and inside or under my hands is the lymph vessel itself, the inside, fluid is going to enter from the tissues through this little crease and into the lymph vessel. And this flap is not going to be wide open. It's going to be held pretty close, or pretty tightly shut, from pressure on the inside that forces this up and against the other flap here, so that not everything can come through, but the lymph is able to make its way through. And then these vessels are anchored or connected with connective tissue all the way around. So here you see what I was talking about. Here's the end of one of these lymph vessels, and these lines here are the filaments that are holding it in place, and then this little line here is the flap, the valve, that allows fluid from out here to be pushed into the interior, the lumen of the lymphatic vessel. Now, what you're going to notice is that the tissue fluid down here, this is tissue represented by these capillaries. It pushes the fluid into the lymphatic vessels, and then it travels one direction back up to the heart, and then it makes its way back into the bloodstream, and then again it goes here. So the lymphatic system and the vascular system are in close communication or tie with one another. The vascular system works in 2 directions, towards the heart and away from the heart, but the lymphatic system only works one direction, back towards the heart. And on its way back towards the heart, you'll notice it passes through other structures like these lymph nodes. Okay, we already said all that. Now, lymph itself, the stuff that gets returned back into the blood, is all the healthy stuff, the water, the blood cells, and proteins. And then the stuff that we don't want returned back into the blood, those are the pathogens, the bacteria, the viruses, and the cancer cells, the things we want to get rid of, and then various other cellular debris that just kind of needs to be eliminated or taken care of. So you've all heard of lymph nodes before. You've gone to the doctor and you'd understand checking these, and lymph nodes get bigger when you're sick. We'll explain today why. And within lymph nodes, the 2 important components, we have our macrophages, which are phagocytic cells that engulf and destroy foreign things. And then we have lymphocytes, another type of white blood cell that provides a targeted immune response against antigens. Here you see all over the body various lymph nodes. They're often found in crevices and grooves of the body. They're spread all over, which is why, in part, the most common area for cancer to metastasize to or spread to first are the lymph nodes, because lymph nodes are often very close to the tumor origin. You'll also notice that we have lymph nodes in the armpit in the axillary region. I always tell a funny story. When I was a kid, probably about 8, I was taking a shower and washing my armpit. Yes, I was demonstrating that for you. And I felt a bulge, a bump in my armpit, and I got freaked out, and I ran out of the shower. I dried off and put on clothes, of course, because that would just be awkward. And I went to my dad, who was a cancer researcher at the time, and I said, Dad, I think I have a tumor in my armpit. Can you check it out? And he felt it, of course, and said, Son, I think that's a lymph node. You're probably going to get sick. And lo and behold, a couple days later, I got sick. So now I have a foolproof method, as long as I soap my armpits, that I will know a couple days ahead of time before I'm going to get sick, because my lymph nodes become enlarged, and I know an infection is present. You can try the same at home. This is assuming you soap your armpits. Now, lymph nodes themselves are shaped like a kidney bean. They have a convex side and a concave side, and then the structure itself has a cortex, an outer region, just like the adrenal gland or the brain that we talked about. The cortex is the outer part, and the medulla is the inner or inside part. With lymph nodes, the outer part contains lymphocytes, such as T cells and B cells, and that specifically we'll get into in the second part on another day. And then the inner part has phagocytic cells, largely macrophages, in the medullary region of the lymph node. So these are going to help to identify the pathogen and then to mount an attack against it. Here we have the actual structure itself. You'll see with some labeling and so on. You don't have to know all these different parts. The important part from this is that you notice the number of efferent vessels, or vessels coming into the lymph node, and the number of afferent vessels. I like to describe this as the 5-805 merge, where you have 4 or 5 lanes entering and 4 or 5 lanes entering from this merge, but then when it leaves, it only leaves as 4 or 5. So 10 or 8 lanes becomes 4 or 5, so you cause this traffic buildup all the time, which is intentionally what is trying to happen in the lymph node, because all the lymph is going to slow down inside the lymph node, and all these white blood cells that are stacked in here are going to now have time to work on identifying these foreign invaders that are trying to cause you harm. And so this is just describing essentially what I just did with my freeway metaphor. Now, lymph nodes are not the only structure. Lymphatic vessels are not the only structure that are part of the lymphatic system. We have others, including the spleen, the thymus, the tonsils, and Peyer's patches that we're going to focus on here. Now, first off, the spleen is found on the left side of your body, left side of your abdomen. When we dissect cats later, many of you will find that in the digestive region, in the gastrointestinal tract, and you'll ask what it is, whereby I will say it's the spleen. It actually has nothing to do with digestion. It only plays a role in the blood system. Specifically in you right now, it destroys worn-out old blood cells. A long time ago, when you were in your mother's belly, it helped to form blood cells, as we mentioned previously. The thymus sits right on top of the heart. It used to be much bigger when you were younger. As you get older, it shrinks down. It functions at its peak very early on. Right now, its main function is simply to produce the hormone thymosin, which helps to program lymphocytes. Specifically, when white blood cells are made in the red marrow, some become B cells. Those B cells are matured or made in the bone marrow, B for bone marrow. And T cells are programmed in the thymus, the T for thymus. Then we have our tonsils in the back of our throat. Some of you have had your tonsils removed. They're small masses of lymphoid tissue. They are the first lines, or the first identification region of food or things entering your mouth. Some foreign material and bacteria are going to get trapped in your tonsils as the food goes down, and then your tonsils will begin sounding the alarm and trying to identify what exactly that is. If the enlargement of the tonsils or this inflammation doesn't go down, you get tonsillitis, and you potentially could have to have them removed. It can congest and infringe on your throat, preventing you from eating things and even potentially from breathing through your mouth. This is what it looks like if you have tonsillitis. These are the tonsils back here, right beside the uvula, this punching bag thing hanging down. But these tonsils potentially would have to be removed. That is not my mouth. Peyer's patches in the intestine serve the same function as tonsils. They're found all around all these microvilli in the intestines. These are normally, the microvilli are for absorbing nutrients from your food, and mixed around you have all these Peyer's patches, which again capture and destroy bacteria like we saw with the tonsils. All these things together we call MALT, Mucosa-Associated Lymphatic Tissue. It's basically lymphatic tissue that's found in the mucosal lining of all over your body. And again, they work to identify and mount an immune response. And on this note, we're going to take a break. Part B coming up.